Hey folks, in this video we're going to look at a more advanced traversal technique. So we're going to look at retrieving a specific node. Now in the previous video what we looked at is basically looping over every single node. So this is great, and it's great if we want to basically apply an operation to every single node in the list. But sometimes we need something a little bit more general. Maybe I want to somehow change a node in some way. So what could we do? We could think about basically writing a function to select a particular node and return it. Okay. Now, in order to do that, we'll of course need a pointer to the front of a list. Okay. So over here, right, you can imagine that I have this list over here, which contains in it these three different nodes. And maybe I want to basically select this node over here so that I can do something to it. So this would be fine. Now, we could implement it just using the standard traversal stuff we did earlier, but the problem is it's not really a general solution. So if I wanted to, well, depending on what I want to do with my node, right, I need to basically support different things. Now, if I just want to display it, then it's easy to have a while loop that loops to it, right, and returns it. That's fine. But imagine if I wanted to return a node, and I wanted to be able to use that to maybe implement something like delete, right? Well, the problem is I can't basically return a node directly, because if I return a node directly, it would actually make it impossible for me to remove it from, for example, the middle of a list. Now, the reason for that, right, is if I want to delete from a place, I need to update the next variable of the node for the node that comes before it. Now, when we did delete for our simple example, we were deleting from the front, and the next variable, if you would, was really that list variable, right, the one that's basically on the outside, right, that keeps track of the first node in that list. Now, if we were going to basically select a node in the middle of the list for doing something like eventually deleting it, the problem is we can't just select the node itself, right? We have to select the node that's before, the node that's previous to it. And so that's what we're going to look at. So we're going to write kind of a more advanced traversal function that'll loop over the entirety of my list and basically check for where have I gone to the node that I want to get to, and then once I've gone to it, it'll return the node that's previous to it. So it won't return the actual node, it'll return the one just before it, because if you return the one just before it, well, then you'll have the ability to go back and do something like, delete the node that comes after it. Okay, so this is kind of a way, right, that would support us doing some more advanced changes to a list inside of it. All right, now we have an idea of what we're doing. Actually, let's take a look at the picture really quick. Which we have an idea, right, the problem we're trying to solve. So how do we solve this problem? The way to solve this problem is actually by basically introducing another pointer, right? So before in traversal we had this thing going on where we had basically iter, and iter would know about a node, right? And it would just move iter along, right? It would go from one node to another. We're going to actually have a second variable as well called previous. And previous will be a second kind of a reference, right, that moves with the first one. They're always going to be in step. They're going to be one behind another, one behind another. It'll keep track of what came before me, right? And if you have that, well, then you'll be able to see, what is the thing before you, and return that when someone is looking for a particular node, right? So you'll be able to get access to that part of the list, right, and be able to update it however you want. All right, so we're going to have these two pointers walking on the list. Now we have that also in mind. Let's jump to NetBeans and let's try actually implementing this. So here I am back in NetBeans. Let's get started. So I'm going to add a new function over here, and I'm going to call this, we'll call this select by name. Actually, let's go, select by name. So select by name. Let's see, what do I want to do? I am basically going to check to see, well, let's see, I need my return types and I need my arguments. So select by name. Return type is probably going to be a contact node, right? So I said I want to write a piece of code that can return another node. Okay, so I just like that. Okay, what do I need to take in? Oh, well, I'm probably going to take in the front of the list, right? So this looks a little bit like that traversal one we did. All right, so let's see. What do we do now? So we had this idea, right, that we would have an iter variable and also a previous variable. So let me add those. So I'm going to go struct contact node prev equal null, and struct contact node equal, well, iter equal front. So these are going to be my two arrows that are side by side and are working their way through my linked list. All right, so I have previous and next. What do I need to do now? Well, I need to basically loop over the list. So I'm going to go to the following. Well, iter not equal null, do stuff, right? So let's see, we got that going on. So let's see, I'm looking through my list. Basically what I do is I want to compare the node I'm looking at to what is it that I basically am looking for, which I just now realize I kind of forgot. So let's see, let's take in maybe just something like a char star, right? Something super simple. So char star, and we'll call that name, okay? So that's what I'm going to look for. So maybe I can look up something. Let's see. So I'm looping through every node. What I want to do is compare it. Compare it with what I'm looking for. So I'm going to do the following. If str compare, let's see, iter name and name, right, the parameter, equals 0, then I have a match. I have an exact match. So in that case, right, I'm good. So I found exactly what I'm looking for. Now, the way we described it in the previous slide is we said that, hey, when I find something, I'm not going to return the node itself because that restricts the things I can do. Rather, I'm going to return the node before it because then I have kind of a reference for, like, if I want to delete this thing, how do I, I can actually update that. Right? I can update it. So let's see. If okay, so we have those things match up. We'll inside of here return previous. Okay, so that's our so we return the node before the one we just found. Okay, now else what we want to do is what? We want to basically move forward our other variables, right? So if we didn't find what we want, right, we got to move these forward. So we've got to move previous forward, right? So we're going to set previous equal to iter, right? So we're going to move that arrow forward, and then we'll go iter equal iter dot arrow next, right? So we're moving both of those arrows forward, right, to go to kind of the next place. Okay, so we have that, and yeah, that should be pretty good for us. Let's see. One thing we might want at the end is this additional line to say, return null, right? So if I go through the whole thing, I don't get a match, just return null. Okay, so that looks pretty good. That'll be our technique basically for looping through, right? Bring those two pointers through there. Again, this is what you need, right? If you want to do something like a delete in the middle. So let's try using this just to find a particular node. So let's do select by name, and we'll try what? I want to basically have all three of these in here. And I will go and I will do something like, for example, struct contact node s. Well, I'll call it needs to be a pointer type, right? S. It needs to be a pointer, right? So I'll put a star and then I'll call it s equals select by name, and I'll put in here. Let's say I want to select Wonder Bread, right? The last thing in there. So selected by Wonder Bread, and then over here I'll put in list. Okay. So this should give me basically a well, if the code works, right, this will search the list, loop through every one, and basically return that node that contains that Wonder Bread name. So let's see. So I have that, and then we'll adjust a couple things here. Let me move my code down a little bit. So that there was to create my three nodes, right, and then display them. Let's say I have this. So we'll call this now S. We'll call this select or cell. Yeah. Okay. So this should, in theory, basically search through my list, check every node in there to compare it to Wonder Bread, and then when you get to Wonder Bread, it'll return the thing that's previous to it. Now, real quick here, note that we're not actually going to return Wonder Bread, right? We're actually going to return something else. We should actually return test, right? Because test was added after Wonder Bread, right? So test is basically before it. So let's start running this and see what we get. So we run and we see that we get test is basically printed again, right? So it was able to find that node that was previous to Wonder Bread. Now, of course, this is nice because if I want to do something like remove Wonder Bread, I can actually do that, right? So this here, I'll do this as a very kind of hacky example, but just so you guys can get some ideas here. Here I'm looking for Wonder Bread. I found the node before it, and what I can think about doing is basically going to that node cell and then going next equal null, right? I'll actually need two steps here. Really, it should be something like in a function or something, but for now, we'll just kind of do this really quick here. Wonder Bread's at the end, right? I don't have anything after Wonder Bread. So I could do over here, I could do something like free of cell of next, right? So that basically says delete the node that comes after the node I just returned, which is the previous of Wonder Bread, meaning that this is to free Wonder Bread. And then I'll set that next equal to null, right? So this is basically to delete that node delete that node there, right? I went and searched for it, returned the previous, and now I'm deleting the ones after the previous one, which is really the node I just found. So I'll go ahead and run this, and hopefully what I get is basically the three nodes over here, and over here I should get just the first two nodes. Only that's not what I get because I have a bug, and my bug is a missing semicolon, so this needs a semicolon over here. Take two. There we go. Now it runs, and here we go. Right, the first three things display, and then these two over here. Let's see. So that's basically to delete that one node there. Another example. Let's say we want to delete test. Let's put test in here. So we have test over here. Right. So now we're going to return hello. Let's see. How do we do that? we would actually do a couple things here. So we would actually do the following. We do cell next equals cell, because you can picture in your head, right? You have those three nodes back to back, right? You search for the middle one, you return the previous one. How do I splice out that middle one? I do something like this. Cell next, right? So the thing that comes after that one that I just found is actually a thing that came after the thing that came after the thing that I found, right? So I'm just stepping forward a little bit. And then I probably need to have some sort of a free operation somewhere. And I mean, to do this properly, I need to have this here. We'll go temp equal that, and then over here, free of temp. And I'll clean that up a little bit over here. Okay, so we went searching for a test. We returned the previous node. We saved the reference to that test node that we want to delete. Then we updated the previous node to slice it out, and then we freed temp. So if we do this, we should basically delete test, right? We should have basically just our hello and then Wonder Bread. So let's run this and see what we get. We get a nice error, and our nice error is about yet another missing semicolon. So I'll go ahead and put that in over here. Let's run this, hopefully get it to work. And there we go, right? Hello, Wonder Bread. All right, so there we go. So that was traversal, right? It's a little bit more advanced technique. This is what you want to do if you want to eventually support deleting a node. All right, so that's all I got for this video. Hopefully you now have a better idea of how to work with linked lists in C.